Good morning, good afternoon, good evening to everyone listening to me, depending on where you're listening from. My name is Benjamin, and I'm delighted to present to you a paper titled Bandits Using Fuzzy to Fill Knapsacks, Smallholder Farmers Credit Scoring. So we will give some little background on what motivated this research. And currently, what happens is that lenders, when they're lending to any set of borrowers for that matter, they have most of the risk scoring mechanisms are rule based. There are particular criteria that have to be checked against, and where a borrower satisfies some particular threshold of score within the set of rules, the lender borrows, extends the credit to that particular borrower. However, where a loan seeker or a borrower doesn't satisfy, either he falls short of that particular threshold, either the loan can be denied or it can be extended to the borrower at a higher price. Now, two problems arise from this thinking, especially when you're looking at smallholder farmers. One is that the smallholder farmers, the kind of data that you get from them is full of outliers and missing data, and that in itself can be a source of bias. And so it necessitates some level of human judgment when you're looking at such outliers and missing data, which is normally very difficult in the current rule-based mechanism based on crisp thinking. And so that is the motivation why we are looking at using imprecise thinking, near human judgment thinking, which is offered by fuzzy logic. And the other challenge is the rapidly changing farming environment. Now, the rules, if you set them at once and use them over a long period, definitely in this field they will fail to apply. And so we are looking at how can we have a changing set of rules, changing with the times. And so that is why we are proposing the use of an exploit mechanism offered by Bandits with Knapsack. The objectives of this research were twofold, we could say. The research is aimed at proposing a self-improving mechanism for risk scoring. Of course, we've said based on explore, exploit. And then the other objective is to propose a near human thinking risk scoring model that can also be as low cost as possible given the set of borrowers that we are looking at. And in this case, we're looking at a computerized risk scoring model. In the experimentation in this research, we used data from smallholder farmers and from financial institutions, which we subjected to analysis. So we'll provide some background to fuzzy logic for the purpose of understanding the fuzzy logic. We'll use an example, assuming that a lender uses age as a criteria, as one of the criteria to assign risk scores, where a particular age bracket is assigned a particular score. In this example, the first three sets giving an acceptance resulting to acceptance, and then assuming that this is purely hypothetical, assuming that older borrowers have higher probability of default. With that kind of thinking, there is likely to be some bias, especially when you're looking at the people whose age falls at the extreme ages of the acceptance or rejection age. Now, for example, someone who is age 49 or age 50 will be accepted, but someone who is age 51, who is very close to age 50, will be rejected. And this is some form of bias. And so what we will look at is introduce a new concept, the concept of the degree of belonging. So we say that age 51 has got a lower degree of belonging on the rejection bracket as compared to age 60. Age 60 has a higher degree of belonging in the rejection bracket. And so that concept of degree of belonging is what is the key concept in fuzzy logic thinking, with each entity assigned 3 particular numbers: the lower limit, the middle number, and then the upper limit. And so again, we introduce another criteria, another concept, which is now the rule function that we intend to use. And as a departure from the Lagrange function used by Mollica, we intend now to use a fuzzy set. Now, before we look at the fuzzy set, we look at the repeated incremental pruning to produce error reduction algorithm, which was the precursor to the fuzzy unordered rule induction algorithm. Now, Reaper is more or less the same as Fourier, with the Reaper being a rule induction algorithm using crisp rules, whereas Fourier uses fuzzy rules. And this is the departure from in this the key departure in the key introduction in this particular research. And so, going back to the data that we got from the field, we looked at 23 different data, and we got feedback from both the borrower's perspective and the lender's perspective, and we looked at only the data that there was consensus. There was some level of consensus that it was important, and this drove us to 14 sets of data. The whittling down from 23 to 14, we put a threshold of 2.5. Anything that was having a score of 2.5, both from the lender's perspective and the borrower's perspective, we took it as genuinely important. And so just a few questions that we ask ourselves. One is, can fuzzy work with credit risk scoring? And maybe even to extend it further for risk scoring for smallholder farmers. And the essence of asking ourselves this question is because other scientists have in the past raised questions about whether fuzzy can be used for real life, as a solution in real life problems. Then we introduce another concept, that's multi-criteria decision-making method. Risk scoring being such an example of a multi-criteria decision-making method, where we have, in this case, 14 different criteria that we would like to use to make a decision on whether to lend or not to lend. And then we also look at a fuzzy analytical hierarchical process as an example of a multi-criteria decision-making method. So we say that credit risk scoring is a multi-criteria decision-making method, and we will use fuzzy analytical hierarchical process to determine whether the data that we have is fit for use in credit risk scoring. Generally, fuzzy analytical hierarchical process is a multi-step process, taking a whole range of steps, but with the goal of determining whether the data that is at hand can be used in a particular classifier or not, in a particular fuzzy classifier or not. So the goal is to actually confirm whether the data that we have is fit for use in a decision-making process. And in the step 4 of the various steps that we have indicated is the pairwise comparison of the various criteria. And so we make a comparison of the various criteria by dividing one criteria value by the other. In this case here, we are dividing the fuzzy numbers, not crisp numbers. For example, age is fuzzy number 2, 3, 4, and source of income fuzzy number 4, 5, 6, giving a pairwise comparison of 0.5, 0.6, 0.7. And from these pairwise comparisons, we work out the consistency index, which is a simple ratio of the weighted sum values and the number of items in that set. So having obtained the consistency index, we calculate the consistency ratio, And in the calculation of the consistency ratio, we use the SATI random index. In this case here, for n is equal to 14, it evaluates to 1.57. Now, SATI is the researcher who came up with the analytical hierarchical process, and he set a benchmark of 0.01, meaning that since our consistency ratio is significantly lower than 0.01 threshold, it is fit for use in the multi-criteria decision-making method. We have so far introduced a few key concepts. That's fuzzy logic. Then there is a fuzzy unordered rule induction algorithm, Fourier. And then the third one that we've introduced is fuzzy analytical hierarchical process. Now we introduce a fourth concept, that's bandits with knapsack. Think about a bandit who has a knapsack, and that knapsack should be filled with money. The knapsack has limited capacity. That is one limitation. The other limitation is that the cassettes are also of different capacities. And so the bandit needs to fill as much of the cassettes into the bag, into the knapsack. And then bandit does not know ahead of time the various sizes of the cassettes. And so what the bandit uses is an exploit mechanism to make sure that the knapsack is filled with as much as possible by exploring the environment and then using exploitation to fill the knapsack. And so on an overall basis, the mechanism that we are proposing is a multi-armed bandit with the knapsack with a capacity, a limited capacity B, which is, and the bandit is using an exploit-explore algorithm, which is based on a fuzzy unordered rule induction algorithm, using the specific data set that we have specified as being fit for use in credit risk scoring for smallholder farmers. And this way, the goal is to make sure that the capacity or the lending capacity of the lender is fully utilized, while also getting quality borrowers into the loan book, and there is no disenfranchisement to the borrowers. And so in conclusion, we looked at an exploit mechanism in which bandits with knapsacks provided a desired dynamic credit risk scoring for smallholder farmers. And we proposed the use of Fourier, that's a fuzzy unordered rule induction algorithm, which gives us near human reasoning results at low cost. Now, near human reasoning because it gives the element of imprecision, moving away from the precise, crisp thinking. So the paper assumed a stochastic linear function, which actually, looking at it from a risk scoring perspective, might not be very accurate because it's never that linear. And so we propose further experimentation on adversarial functions, which may produce better results. And then also another proposal from this paper is that lenders should actively engage ICT professionals to to consider building their risk scoring methods, algorithms based on bandits with knapsacks and fuzzy sets. And so thank you so much for listening to my presentation. I would like to respond to any question that may arise from this presentation. Thank you so much.